We are actually pretty on time. I was just talking to a cisp360 instructor right before this, and I told her, where we are at this point. We are done with subroutines, passing by value, pass by reference, arrays. We are on structures or records right now, and she said, "Wow, okay, that's actually pretty good." So I think we are not far behind. Okay, we are definitely not. So this needs to be updated too, because otherwise it's going to be recording the screen wider than you see on the screen here. So I'm going to have to fix this too. This seems like I have to do this almost every class now. There we go. And the voice is, streaming is on. All right. So when is our final exam? We talked about it at the beginning of the class. So with Google search, you can look for ARC final exam schedule. Okay, and that usually lands you on the right page. This is spring, which is not what we want, but you can click on the link here, ARC final exam schedule, and this particular one is the correct one. So we'll go ahead and see if I can magnify this a little bit. Yes, we are. All right, so this is your final exam schedule, which changes from semester to semester. But this defines, when each class is going to have the final exam. But this class is not a full semester class, so these dates actually do not apply to us. If this were a full semester class, which is in most cases, cisp300 is a full semester class. But this one is a second 8-week class, so it doesn't fall into these particular dates. So let me look for the part that is applicable to second 8-week classes. Short-term classes, right there. So this class as a second 8-week class is considered a short-term class. So as a result, we'll have our final exam during the last class session. So the last class session for this class, okay, so now we have to know when the final exam is going to start. So according to this, the final exam week starts on December 14th, which is a Friday. So we are definitely not having our lecture or exam on December 14th. Instead, our final exam is on December 12th. Okay, because December 12th is the last class session for this particular class. So that's also when we're going to have our final exam. So you might want to write down on your schedule or calendar, at this point, to make sure that you mark that day, which is 12/12, okay, December 12th. And the time is going to be the same, so we will have our final exam from 6 to 8, not 8:05. So we'll be 5 minutes short on that day. So are there any questions? Yep.
We're actually having it 9 days from now.
That will be 9 days from now.
12, that's 5 days. Cool.
So there are still a lot of classes in between. Yeah.
There's only 3 class sessions left between now and the 12th. Today, Friday, Monday,
Today, Wednesday, Friday,
and Monday.
and then Monday. And then it's the final exam. Okay. Yep, that sounds about right. That's, yep, well, this is what happens when you squeeze a normally 16-week 3-unit class into a second 8-week class. Is that the first time some of you take a second 8-week class that has 3 units? Okay. Yep. It's kind of the same feel as a summer class. When this is taught as a summer class, that's how the timing feels like too. All right. So this is a good page to remember, how to look for the final exam schedule in case it's not in the syllabus. In this case, it is in the syllabus. Yep.
I know this might be in the syllabus, but is the final cumulative, or is it just
The The final exam is supposed to be from the second exam in terms of the material, from the second exam to the last class that we have. But since we did not have a second exam, so that means it's going to be from the first exam to what we are teaching now. So the scope is going to be increased. But with a programming class, it is pretty much impossible to be, not to be comprehensive. In other words, we talked about assignment statements at the very beginning, right? So it's almost impossible to write any algorithm that is actually useful without assignments or conditions or conditional statements. So the class is naturally kind of cumulative. It's pretty hard to make it non-cumulative. It's not like a history class where you can say, okay, this class, will only cover from this century to this century, because they can have a clean break based on time, and we cannot, because this is a concept-based class, not a fact-based, class. So is that answering your question? Yeah. Okay. It's still going to be open book and open notes. Okay, those same restrictions of no electronics as the first exam. So, now would be a good time to start to prepare for the final exam. Now that you know the scope, you know when it's going to happen. Yep.
Just a reminder, how much percentage of our grade is the final exam?
So the final exam is 53% of your grade, and then the first exam is increased from 20 to 27%. Yep. So that means if you, let's see, 53%. So that means if you get half of the answers right from the first answer, and then you ace completely the final exam, you'll still end up with a B, even without turning in any homework.
What's the minimum for a beat again? That's like what, 20 tests? That's like 40, 60?
Syllabus. For B, 62.5%. Yeah. Yep. All right. Any other questions?
Do you have a sample?
Yes, I'll give you a sample test on Wednesday. So I typically do it like one class session with one class session between the exam and the practice exam. So I can do it on Friday. There will still be one class in between, or I can do it on Wednesday. So I'm thinking about sometime maybe on Wednesday. But then I also want to cover just a little bit more material. But we got most of the basic stuff done already at this point, so we are good. All right. Yeah. Well, it's mostly because it's not a full semester class. If this were a full semester class, then we will have our final exam on the 14th or after. So, any other questions? No other questions? All right. So if there are no other questions, we're going to go back to the material of this class. And we are already on the very last slide, types and records. Yep.
Are we going to go over the homework?
Sure. Yeah, let's go over the homework. So the homework is...
Slide of the class, or was the other one with Jigster's records and all that?
Well, if it's due midnight tonight, then I cannot go over it yet. Yeah, so because it's due, so you can still turn it in after class today, so I cannot talk about the solution. But if you have concept questions about the homework assignment, we can talk about that. Nope. Okay. All right. So we'll get back to question. Yep.
So types and records is the last slide for the class?
It's the last module for this class. Yes. Well, we actually started this last week. Yeah. And we talked about notation. We talked about record, the record definition already. And we talked about the example already, too. I think we went through a trace even. Yeah. So are there any questions about that particular trace? I'm kind of relying on you guys to review the material when you get home.
A lot of it made sense. It's just going to be kind of going back and making sure we're kind of comfortable with the actual trace itself.
Okay, all right. That makes sense. All right. So we'll have some more examples today. Okay, so we'll go ahead and have some more examples. And let's start with this slide here. I'm just going to remove what was in there because it's not relevant to this class. All right. So let's go ahead and I'm thinking about what kind of record. So we'll define the record type, okay, called performance, okay. So in a performance record, we'll have GPA. Okay, GPA is a number, so it's not going to be integer. It's just a number. What else do we use to measure, academic performance other than GPA? Ranking. Okay, so we can use ranking. But ranking, okay, we can do ranking, because maybe this is only for one particular test. So ranking is an integer. The lower, the better. Okay, and defined and record. There we go. All right. So when we have two performance records and we want to compare and see which record represents a better performance, then we have a question. Because, do we compare the GPA first or do we compare the ranking first? Because GPA is an average, ranking is specific to a particular test. So if ranking is not going to work, we have to choose some other metric for ranking for measuring academic performance. So what else do we use for academic performance measurement? Recordings. How about days missing from class? How many days someone has been absent from class?
Just clarification, GPA is a number, should it be a floating point as well?
Yeah, so that's why it's a number and not an integer. Okay, I know. No, it's because of my watch. The little magnetic thing here is sensed by the laptop computer. The laptop computer has a magnet itself, so when the lid closes, it holds it closed, and it's used as a sensor, so the PC knows when to kind of turn off the screen and turn itself off. So unfortunately, my Fitbit has exactly the same kind of magnet. So when my hand is at the right position, that can turn off the computer. So I have to remember to take off my watch when I use the computer. Okay, so I know this is nap time in class. Okay, like the number of hours somebody has napped during my class. Is that okay? Okay, so we'll use these two, to rank, academic performance, and you guys will be surprised, how I, use these two numbers. Okay, so I'm going to write a subroutine, define sub, and then we'll say compare. Okay, compare performance, kind of a long name, and define sub. So obviously, it will need two things to compare. So in this case, I'm going to pass by reference, not by value. So I'm going to pass by reference two things. So we'll have the performance record 1, which is a performance record. And then we'll also pass by reference record 2, which is also a performance record. So now I need to compare these two. Now obviously we have two numbers. We have GPA, which is your typical GPA from 0.0 to 4.0. And then nap time is really just the number of hours that I have observed someone falling asleep in class. Is that okay? So I need to do some ranking here. So the first question is, well, which one is more important? If the other number is the same, which number is more definitively telling me about the performance of a particular student? If two students take the same amount of time to nap in class, okay, GPA is going to be the important one. Okay? In fact, I don't want to look at nap time unless the GPA is the same. Is that making any sense? So I prioritize GPA over nap time. Okay. So that kind of makes sense. So I'm going to say if the GPA of, okay, so when I say compare performance, I have to also specify what it's going to return. So what do you think it should return? No, what kind of result should be returned? So I give it two records. So imagine it's not a subroutine, it's not pseudocode, it's a person, okay, that you're giving two performance, you're giving 2 records to a person, and then you're expecting an answer back from the other person, right? So what kind of answer are you expecting back from the other person? Boolean. Okay, so if you're saying Boolean, then it will only indicate whether a particular record is representing a higher performance than the other record, or lower, right? But what if I want the same answer to indicate A is better than B is better than A, or they're exactly the same? I cannot use a Boolean anymore because there are 3 possibilities, right? Sorry? No, it's just going to be an integer. Yeah, go ahead. So it's going to be an integer. If it's a negative number, it means record 1 is representing a lower performance than record 2. If it is a 0, it means record 1 and record 2 are representing equal performance. And if it is positive, that means record 1 is representing a better performance than record 2. Would that work? So it's just a convention, okay? It's nothing more than a convention. It's negative value, 0, or positive value. Okay, so I have to make it clear first because otherwise I can't specify what result I should be returning. So I can now say if record 1 is the same as record 2 in terms of the GPA, then we have to look at the nap time. Else, I should be able to make a determination here. Okay. So now, if I get to line 10, it means the 2 records, okay, record 1 and record 2, have equal GPA value, or the member GPA has exactly the same value on the 2 records. So I'm going to use nap time here. So now the question is more nap time indicating better performance? Yes, in my book, that is the case. Because if someone can get the same GPA, being asleep like 90% of the time, as opposed to someone else who has the same GPA but staying awake the entire time, I would say the person who napped more has a higher performance. It's kind of counterintuitive. Okay, so in this case, I'm going to return, okay, so this is the fun part. So the more nap time, the higher the performance. So I'm going to say record 1 dot nap time minus record 2 dot nap time. I don't even bother to compare. Because remember, if I return a positive number, record 1 is representing a higher performance. If I return a 0, they are equal in terms of performance. If I return a negative value, record 1 is representing a lower performance. Doesn't that do the trick already? Yeah. So there's no need to compare and then say return -1, return 0, return +1, because as long as the agreement is whether it's negative, 0, or positive, but not in terms of quantity, this will be fine. Is that okay? All right. So the other one can use exactly the same reasoning. In other words, if I ever end up here on line 12, that means the GPA member of record 1 and record 2 are not the same. Well, if the GPA is not the same, I don't even bother to look at nap time because I want to prioritize GPA. So now I'm just going to subtract the GPAs. So record 1 dot GPA minus record 2 dot GPA, that's what I'm going to return. Is that okay? So it is always a nice thing to kind of comment, but since I don't want to clutter up the listing with too much comment, I'm just going to leave it the way it is. Is that okay? All right. So the next thing we need to do is to define the main subroutine. The main subroutine needs to have its own local variables that are performance records. So we'll take 2 people here. So we'll have local variable tag, which is a performance record. And then we'll have local variable George, which is also a performance record. And then we need to initialize some of these values so that we can actually do some comparison. So tag's GPA is 2.0. But he took, let's see, this is a 3-unit class. So tech took 16 hours of naps for the entire semester. And then here's George. George is a very good student with a 3.5 GPA. And George never sleep in class. There we go. So now we want to say if, okay, so this time I need a local variable to store the result because I need to compare it twice. There's no easy way to only compare the number once to find out whether it's negative, 0, or positive. Because there are 3 possible results, and a single comparison can only differentiate between one or the other condition. So I will need another local variable. Oh, nap time. Okay. So I will need another local variable. It doesn't really have a particular purpose other than just having a number to compare. I call it temp. So temp is going to be assigned the result of invoking compare performance. So I'm just going to use CP to abbreviate the function name because otherwise it's just too long and it's going to look really bad in the trace. So I'm going to use CP to represent compare performance. And then we are going to pass tech to parameter record 1, and we'll use George to pass to record 2. And then we'll say if temp is less than 0, then we'll say George is a better student. Let me turn off the ringer. Okay. If temp is greater than 0, then we print tech is a better student. Else, they are equal. Okay. Now, obviously, we will only hit one of the 3 cases, and I think most of you already know which case we're going to hit. There we go. All right. So here's the entire program. I think most of you already know what the result is. So the big question is, when we trace this code, what is the trace going to look like? That becomes the actual question. So let's do that. And we'll use a spreadsheet. And copy and paste the code. Copy, paste. And we'll start the trace with a new window. Okay, I have to fix one little thing because even on my screen, I cannot see the rest of my screen. Not that I really need to, but I just want to get that fixed. It still thinks I'm seeing the entire thing, but I'm not. I'll fix it later. Okay, is that font too big, or I mean too small, or is that okay? Too small? Way too small, okay. And the zoom control is not visible to me anymore. I'm gonna resize it so. Is that better? Okay, so that's a zoom of 140%. We'll do the same thing here. Okay, so we'll have line number. The precondition really has nothing to say. We do not have any global variables. We do need comments because we do have one condition to evaluate. And now we start execution on the first line that is outside the definition of a subroutine. So in this case, it's going to be line 16, or line 36, sorry. So line 36 is the first line, and because it's invoking main, we have to use either return line number or return info. So from here, I'm just going to be consistent with using return info all the time, but you guys can use return line number when a subroutine does not return a value. Yep.
I had kind of presumed that the code that you wrote second would be where it compares the GPA of the two students was a separate program. Is that from the one on top? Is that true?
It's not a separate program. It's a separate subroutine in the same program.
Oh, okay.
Yep. All right, so we have a return info cell, and then we have local variables. We got two local variables in this case. So when we scroll up to the top part of main, we can see we have three local variables. I stand corrected. We have tag, George, and temp as three local variables. Two are records. So we have tag taking up two columns. We have George taking up two columns, and then we have temp by itself. So let me, I know it's not visible, but I have to make the columns shorter so that we can see it. So tag has two members. The first member of a performance record is GPA, and then the second member of a performance record is nap time. Is that okay? So both of these columns, D and E, are really the same. They are in the same variable tag, but they are two different members of that one single local variable. Is that concept okay? Okay, all right. George is the same way because George has a type of performance. It is a performance record. Every performance record has a GPA member as well as a nap time member. So once again, we are going to indicate that column F and G are local variable George. It has two components. So depending on what we're going to do with it, each component can be accessed individually, or we can just treat the entire thing as one whole thing. Temp is easy. Temp is a local variable, which is just starting with an unknown value. So column H starts with an unknown value. And then we have question marks for every single one of these, because every single one is really a local variable. Okay. So question mark here, question mark here, question mark here, and question mark here. The important part, with the 4 question marks is we have to use 1 question mark per column and not just 1 question mark for both columns. Is that concept understood? Because each member of a record is individual. You can assign a particular value to GPA and forget about nap time. Okay? So that's why we need 4 question marks from column D to column G, because each column is representing a particular individual piece of information. And that's why, each column has its own question mark. Is that okay? Yep. All right. All right, so if that part is okay, we get into the subroutine starting on line 20, which is really just a whole bunch of initializations. So we have 2.0 as my GPA, we have 16 hours as my nap time, and a 3.5 GPA for George, and 0 nap time for George. So 20, 21, 22, 24. Nothing too exciting happening here. Actually, 23, I couldn't count. So now we're getting onto line 24. So when we get onto line 24, we are invoking, we want to perform an assignment operation on line 24, but I don't know what to put, what value to store in temp until the invocation is done. So I can't really do anything about the assignment. The only thing I can do right now is to invoke the subroutine. So that means in order to kind of track what we are doing on that line, we have to start allocating new columns for this particular call to compare performance. We need return info cell, and the return info cell is going to tell us where we're going back to and what else we need to do when we get back. So we need to kind of get back to the invocation on line 24. So on line 24, the assignment still needs to happen when we return from the subroutine, but by the time the subroutine is done, we should have a return value. So the question mark is representing a placeholder for the return value of the invocation of compare performance. Are we okay with how we set up return info cell? Is that okay? All right. And then we have to pass the parameters. There are two parameters. The first parameter to pass is to record 1. So record 1 is the label of the first parameter, and then we have record 2 as the name of the second parameter. And you might say, oh, do we really only need one column J for record 1? Because that's a performance record, and performance record has two members. Well, because it's passed by reference, so there's only one single reference, even though what we are referring to has multiple columns. So that's important, okay? It's kind of like, you have a street address to a particular house. Does it matter how many people live in that house? Nope, it still has the same street address, because the house is quote unquote a container of the people who live in it. You can have one person living in the house, you can have 5 people living in the house, but it has the same street address. Same thing here. So record 1 is a reference to the columns that is occupied by the thing that we use to specify record 1. I use tag to specify record 1. Tag is using column D and E. So over here, I'm just going to say record 1 refers to columns D to E. So likewise, we're going to say record 2 is a reference to columns F to G. Is that okay? All right. So I'm just moving it enough that we can see that part. Actually, I still need to make the window smaller. There we go. So I'm going to use this trick to split the screen so we can keep track of line number and comments without having to move the cursor a whole lot. There we go. And here's the context of where we're executing. Now we get back to the source code. And here's compare performance. Once we set up all the columns, we now continue execution at the beginning of compare performance. So this is starting on line 9. On line 9, it is a comparison. Comparing the GPA field against the other one, the GPA field of the other one. Are they the same?
No.
They're not the same. It's false. Okay. And I'm going to make this wrap around so we can see the entire thing. Format cells and rep text. There we go. All right, so if it is false, then we go to the else branch, which is on line 12. Line 12 is a simple return statement, because all it wants to do is to find the difference between the two GPA members, and then whatever that difference is my return value. So in this case, looking at column J and column K, I cannot really know the difference, but I remember my GPA is 2.0 and George's GPA is 3.5. 2.0 minus 3.5 is negative 1.5. So negative 1.5 is the return value. So when we know the return value, we can execute the return statement on line 12, which involves really just changing the question mark to the value that we are returning. So we copy and paste it, and then we just change the question mark to negative 1.5. Are we going to update the column corresponding to temp in main at this point? Nope, we just changed the question mark, okay? So after line 12, we get out of the conditional statement, and there's nothing to do after the conditional statement, so we get to the end of the subroutine, which is on line 14. So that has two things to do. One thing, the first thing is to take note of where we are going back to and what else we have to do when we get back there. So that's going to be going back to line 24, and the assignment operation can occur once we get back. The second thing we have to do is to deallocate the columns that we have allocated for this invocation. So that is that, okay? So now we resume execution on line 24. I'm going to get rid of this. On line 24 in the program, it is finishing up the assignment operation. So we are just computing, or we are storing negative 1.5 to temp. Temp is on column H, so column H is now updated to negative 1.5. Do we have any questions at this point? Nope. Okay. So the rest are pretty straightforward, because on line 25 we just have a comparison to negative to 0. So we say temp is less than 0 is true, because negative 1.5 is less than 0. Then we get down to line 26. Line 26 is only there just so that we got something to do. So it is printing George is a better student. And then we are done with the then branch, or the then of the outer branch. So we get out of the outer conditional statement, we get to the end of the main subroutine. So on line 34, we take note where we need to go next based on the return info cell. You can also use a return line number cell if you want to. And then we have to deallocate all the columns. So that's going to be all of these columns here. So there's a total of 6 columns to deallocate in this case. So we copy this and then paste it over here, and then just indicate that we are deallocating. So when this is all done, we continue execution at post, which means we're all done. So are there any questions about this trace? No questions about this trace? Are there any questions about the representation of a record as a local variable? How we declared the local variables Tech and George? Are there any questions about passing a record as a variable by reference to a subroutine? All right. No questions? Cool. Should I wait a little bit, or are you guys okay and ready to move forward? Okay? All right. All right. So getting back to the slides, okay, so here's the record add, complex add. We talked about this last time. Record, formalized. Array of records. I don't think we have started on array of records yet. Okay, so we can talk about this one. So in this case, we have student as a record type. So in this case, I did use string, okay, so there's first name and last name and the GPA with the student record. And I defined an array of students in order to get it into binary search. So the importance of this particular algorithm, so if you look at line 10 to line 23, well, maybe line 22, that looks exactly like binary search, okay? But every single time we compare, we have to compare a particular member of a record to the value that we are searching for. So I want you to kind of pay attention to line 17 and also line 19. Do you see how on line 17, we are not comparing an element of the record directly to V. Instead, we are comparing a member to V. That's because as a record, it has multiple members. And with multiple members, we don't know, the computer doesn't know how to compare multiple members to a single value. So you have to designate and say, do you mean to compare the last name, or do you mean to compare the first name, or do you mean to compare the GPA? Pick one of those to compare. Because the comparison operator, less than, greater than, equal to, not equal to, those can only operate on numbers and strings. They cannot operate on record types. So there's no actual way to compare two records directly. You always have to boil everything down to the comparison of numbers and the comparison of strings. So is that okay? And that's basically what this particular sample program is trying to illustrate is, even though we are passing students in as an array of student, when we perform the comparisons, we have to compare to the members of each record and not compare to the entire record. So this particular algorithm can find the highest GPA given an array of student records. So in this case, finding the maximum, once again, we have to say, well, what do we use to specify the maximum? What are we comparing between students to find the maximum? So in this particular case, we are using GPA, the member GPA, as the number to compare. Because once again, when you encounter this less than operator, it can only compare numbers. It cannot compare two student records because it doesn't know, are we comparing last names? Are we comparing first names? Or are we comparing GPA? The compiler doesn't know. It cannot make that decision for you. So when you use operators like less than, greater than, equal to, assignment, and stuff like that, well, assignment is not the same, but less than, greater than, equal to, and so on and so forth, you have to designate which member are we using for that comparison. And that's what this example is illustrating as well. Do we have any questions about this? We haven't really talked about the algorithm to find the maximum in an array, so I can cover that a little bit later, like right after this. Is that okay? Okay, so let's work with the algorithm to find the maximum in an array first. All right, so we'll start a new window or new document. So we'll define subroutine, find maximum. No, we have talked about that already. Do you guys remember when we started to talk about finding the maximum in an array? No, before that. When we first started to talk about arrays, that was the reason why we had arrays. Because we talked about how to find the maximum of 2 variables. Yeah, seems okay, pretty easy. Find the maximum of 3. Yeah, we can extend the algorithm or the logic of finding the maximum of 2 to extend it to find the maximum of 3. What about 4, 5, 6? What about 50, 50,000? Oh, that's not manageable. That's why we need arrays. So that's the first time when we talked about that, okay? but we never talked about it in the context of a subroutine, so it's still useful, from that perspective. So I'm going to use subroutines in this case to illustrate how to find the maximum. So passing by reference is a parameter called a, and a is an array of numbers. Well, make it integers. And that's all we need. So we have a return type here, because from here on, I kind of need to let people know what kind of a value is going to return. So the return type is an integer. I forgot to do this with the previous example. I need a local variable I, because I need something to help me keep track of the index of the array element that I'm looking at right now. And I also need another local variable to keep track of the index of the maximum value in the array. So we'll call it m here. All right, so now we have all of the necessary local variables and the parameters, and we can get started. So the way we start is I initialize m to 0. What this means is I am assuming the first element of the entire array is the maximum. Well, isn't that a little bit premature? Absolutely. But before I have any comparison to other elements, I'm just going to use that assumption. Okay? I'm just saying I'm assuming element 0 is the maximum unless somebody can tell me otherwise. Okay? And once again, m is not the value of that array element. It is the index of the array element that has the largest or maximum value. So the assumption that the first element of the array has the largest value is why I am initializing m, which is an index, to 0. Is that okay? Well, if I make that assumption, I really do not need to start with element 0 when I start comparing, because otherwise I'll be comparing element 0 to element 0 itself, which is not going to be very helpful. Okay? Is it wrong? It's not wrong, it's just not productive. So I'm going to start with element 2 when I perform comparisons. So here I have a loop. And in the loop, I need 2 conditions to stay in the loop. The first condition to stay in, well, actually, I only need 1 condition, excuse me. I only need 1 condition to stay in the loop. The index I, which is the one that's going to change, has to be less than bar A bar. Bar A bar, once again, is the number of elements in array A. Because when I equals to bar A bar, I is no longer a valid index. So it doesn't really make sense to do any more processing at that point. So it's time to get out of the loop. Is that okay? Okay, so now we have a loop here. And I know at the end of the loop, I have to increase I by 1. So I'm going to put that in first. So the next question, yep.
We have the other part of that where it's, it can't be the sorry, it can't be the same number that you're looking for.
I'm not looking for anything. I'm finding the maximum value, or I'm finding the index of the largest value. Right, so what am I going to do? So at this point on line 9, I know that I is a valid index. I know that m is the index of the largest element of the array up to this point. I know index I is the index of the element I should be examining at this point. So what should I do? What can potentially happen?
A bracket AI and AM.
I should compare A bracket I to A bracket M. Okay, I'm intentionally missing the comparison operator so that we can talk about it. Okay, so if A bracket I is less than or equal to A bracket M, what is that telling me?
A bracket M for now is max.
It continues to be the maximum, okay? Because A bracket I, the element that I'm looking at, that I'm scanning up to this point, is less than or equal to the element that I think is the maximum. So that's fine, okay? The assumption is holding. What if that is not the case? What if A bracket I is greater than A bracket M? That means my assumption is wrong. Because, remember, M is supposed to be the index of the largest element of the entire array. Guess what? We just found one thing that is larger than that. Okay, so I guess it's not the largest anymore, so I got to do some updating. What should I update when that happens? M gets I, correct, because M is supposed to be the index of the largest element, and I just found that the current element, which has an index of I, is greater than what I thought was the largest. So the update is just changing M to I. Not A bracket I, because we are not tracking the value, we are tracking the index of the element that has the largest value. And it kind of makes sense that way, because as long as you have the index of the largest element, can we get back to the value of the element that has the maximum value? Yes. Is the reverse true? If I know the maximum value, do I also know the index of the largest value automatically? Nope. Okay, so it's better to keep track of the index than the value. And that's it. This is the code. So when the loop exits, I have to return one thing. So I'm going to return the index of the largest element. So that part depends on how you want the subroutine to work, because sometimes you want to return just the largest value. Other times you want to return the index that has the largest value. The reason why you might want to return the index of the largest value is because once you know which item in an array has the largest value, then you might want to do something about it, like exchanging the value of that element with that of something else. Is that okay? All right. So we'll go ahead and define sub main. This time we have a local variable. We'll call this B is an array of 4 integers. Okay, I don't need it to be too big. And we want to initialize B. So we'll just put some random values here. It doesn't have to be sorted. In fact, if an array is already sorted, I don't need to scan to find the largest or the smallest value. So that kind of defeats the whole purpose of scanning through the array. So the array is unsorted. So we'll have 7, 2, 14, and -6. Okay. And then we'll say print. Okay, this would be fun. Invoke find max. Use array B, local variable B, to specify parameter A. Whatever it returns is going to be a part of the message that I'm printing. So this is the first thing I'm printing, and then the second thing, or whatever follows, I'm going to use a plus as concatenation. So whatever else I want to print is the index of the maximum value. Okay. And define sub invoke main. Do we have any questions about the pseudocode first before we start to trace the algorithm? Yep.
Yeah, I was still writing stuff down when we went over one part, so I'm kind of not sure what's happening on the end if.
On the end if? On line 11?
Yeah.
So,
Mainly, well, I guess line 12 actually,
mm-hmm.
because I know what end if is, but yeah.
Okay, so line 12 is really just advancing the index by 1, because we are now done processing the current element that we are looking at. So we are ready to look at the next element in the next iteration.
Oh, okay.
So I guess I plus 1 on line 12 is preparing for the next iteration, if there is a next iteration. If I equals to bar a bar in the condition, that means we are done with all the iterations, so there won't be a next iteration. But we are advancing I because we are done with a bracket I at this point. We are done processing it.
Okay.
Okay? All right. All right, so let's go ahead and take a 5-minute break, and then when we come back, we'll trace this algorithm so that we understand how this algorithm finds the index of the largest element in an array. The time is, my watch is not on my hand anymore, 59, so 7:04. made the mistake of having two OBS. So let's see, the other OBS is also on. Okay. Not sure whether that's gonna be okay or not. So I'm gonna stop the recorder first. Uh-oh. Oh, hit the wrong button.